We actually have a full talk here from Guillaume. I think I messed up the pronunciation again. Sorry. It's okay? Okay. Well, take it away. Software is an investment.
Welcome. So, last talk before lunch and first talk without hash tables. So, hello and welcome to this talk. I'm Guillaume. I'm not an economist, as you have seen, but this is a talk mostly about money and economy, as you've learned from the abstract. I come from a small business named Auburn Sounds, and 10 years ago I wanted to be more like Walter Bright, so I find myself doing Walter-y things like creating a company and sell products. That happened to use D to make audio effects, and the first project made 2 sales in 6 months. It was a bit of a bummer. I remember my first customer, it was for voice products, and he was using the effect on tiger voice. He said, I wanted the tiger to be more tiger-like. And 10 years ago, it's still just me. I'm still here, haven't died. Running a solo software company is exceedingly boring, but I guess I don't have to go to an open space anymore. So that's that. The main challenge is that you need to create value, and you see it being created in front of you. And you need to create more and more added value with enhanced, processed, and making things better over time. So why D? Why D for B2C product business? Really quickly. Iteration is quite good for design and product success. And D is quite nice at iterations. That makes D adequate for a B2C product business. That's my conclusion after 10 years. So I get to do a bit of everything, but programming is still the main activity. I'm just increasingly bad. What is different is seeing the effects of added value on most stuff, including programming. For example, I like to spend time on libraries. And now that it's on my own money, hard-earned money from products, it feels a bit worse to spend time on libraries. So this is a code quantity at Auburn Sounds, 200 kiloline of code. There's a lot of prototypes because D lets you do prototypes in production code in the same language. Unmaintained, so I don't really pay for prototypes, I think. And looking at my own DConf presentation from 4 or 5 years ago, code size are more than doubled. So that makes me twice as successful as before. So the basic strategy, high level, is to have a closed source product with an open source framework, original strategy. This representation is not really what happens, because actually, physically, core libraries are inside each and every product. And products are quite easy to measure. For example, this one product cost 34K and made 21K. That's a net loss. Estimated value of the product, we can make a simple subtraction. That was easy. End of the talk, you can go to lunch. But what is the value of the core library itself? It costs Z and made W. No one knows. There is no way to separate products from core, in a way. So there must be some value in there, else we wouldn't have created that, I guess. But in a generalized case, it looks like that. We can estimate the value of A. We could estimate the value of B. That's a good start. What is the estimated value of their intersection C? More importantly, how long should we work on it? Half the year? 3 months? What do you mean our business depends on that core thing? So the talk is beginning now. Let's create a toy theory to express nested added value in a way that can represent the former slide. We need first a sort of algebra to describe software parts. Let's call them artifacts. It has a nice ring to it, artifacts. They could be any software quantity, like a byte, a single byte, a keyword, a function, a class object, whole product portfolio. And the main point is to be one same thing. And artifacts would be defined by their extent, which means their content. Artifacts with the same contents would be considered equal, have the same value, because we will introduce a value function later. And one can be contained in another. if it's a subsequence. If A and B share no subsequence, they are said to be independent. A plus B, we are still defining what artifacts are, is putting together the software artifacts next to each other. Then they could overlap or not. Two products, A and B, become a product portfolio, A plus B. That will describe really well a small business using D, for example. And now the value function we want needs this property. If A and B are independent, they share no subsequence, their value shall add up. In short, we want value to follow the extent of software programs. I want that. I don't know if you want that. And ideally, if two programs share no subsequence, we consider that value to be unrelated, or at least that such a decomposition in unrelated artifacts exists. So this is the big postulate of that theory, and that isn't true. Please forget about this talk. We'll simplify problems by saying, oh, we'll just take a software diff, the independent program that isn't related, or at least their value isn't related to the rest. So now we can come to a first definition. Value of artifact A, V of A, is all value derived from A existing. So I thought this was my idea, but as I watch other DConf slides deck about to know the number of slides I was supposed to produce, I stumbled about this quote from John Colvin 2 years ago. So in fact, the value of the code is the present value of all its future costs and benefits. That's the definition we are going to use. And now we can define an asset and a liability. If it's positive, it's an asset. If it's a liability, it's negative. So they will be defined on the same one-dimensional axis, just with different polarity. But there are two words for them. To have this result, we need to consider time, money, attention, or effort as the same thing. And indeed, this whole talk time theory is a very simplified model of the world, as you have seen. So we map everything to the one-dimensional value and see what happens, which is the goal. Now that we have defined assets and liabilities, we can give advice and sell books to make a successful software company. Acquire assets and do not acquire liabilities, which is a strategy advised by Kiyosaki to become rich in general. And it fills one book, so go forth and prosper. And we need case study to validate or invalidate what we've seen so far. Our first example, a large amount of value is created far into the future. In 300 years, someone unearths your JSON 9 parser, the package, and built $100 tera of value out of it. Perhaps with the inflation, that won't be much at that time. I don't know. Propelling humanity into a new space age. This is the accidental space age case. Somehow, I like to continue the story. When the dub registries stop responding, a hero emerges that will change the destiny of civilization. But let's just focus on money. Let J be the JSON parser. V of J is 100 tera inflation-adjusted dollars. And V of J is not knowable without seeing the deep future. We couldn't have foreseen so much value creation. So we should accept that the true value of your precious IP is not known. It cannot be known yet. What we can do is compute an estimate and call it a day. We just use estimate. So V of J is 100 tera dollars, but estimate tilde V, the estimation of V of J, is 0 because no one knows the package now. I'm sorry. So a quick look at the world will convince you that value is further distributed across different actors/entities. Me and my boss, my employees, maybe. In V of A, we conflate everything together. For the business, value could be sales, velocity, more opportunities. For the workers, values could mean wages, the pleasure and pain of knowing a code base, and expertise maybe. For users, value could mean the price of the license, increased learning, brain damage, perhaps the utility of operating the software. So V of A is everything at once for everyone. Another way to put that in the equation is that double sum because this talk is about putting it in equations. In our definition, value can be split in actually 3 different ways: over time, over entities, and over the extent of artifacts, which we have seen in the first part. Which lines of code holds value? So far, it's still useless. So we need a second case study. A scrapping company, Totometrics, hires Ben the contractor, the famous contractor, to make a small bug fix in their JSON parsing library. Please fix a bug in our JSON parser for $500. Ben answers, I will do it instantly. Win $500, learn nothing from it, and we'll never meet again. Ben doesn't take ownership like a goddamn fool. Let's model that with boxes and arrows. Artifacts would be the pink circles and entities are the green rectangles. And what Totometrics is saying is please change G to the independent artifacts, G plus F for 500. Because of our earlier postulate of nested value, we posit the existence of F, independent of J in terms of extent and value, that represents the software diff of the applied change. And this is what Totometrics is thinking. We thought at the meeting that the estimated value for us, T, of F was superior to 0. Because right now it sure looks like we will lost $500. So the decision for the business could be written like this. And considering our world as only Totometrics and Ben the fixer, there are only 2 entities, so we can decompose tilde V into tilde V for T and tilde V for B, Ben the fixer. So we arrive at that equation. There's a glitch because I fixed it 5 minutes before the presentation because it was wrong. In Ben's point of view, in software's investment terms, I have no real exposure to J, only to F. So the value of J for B is 0, but the estimated value of F for B is $500. Glad I went to that training. So if we mix the equation, we arrive at the estimated value of F must be superior to $500, which makes sense since only Totometrics has exposure to the changed software. Most decision problems will converge on something like this. Estimated value of the software diff for whoever asks the question is superior to 0. If we model build versus buy decision, we will find that the value of the dependency created and maintained must be greater than the value of dependency used. And by the application of the postulate from before, we will find the earlier form. It is worth it to do the change if it's worth it to do the change. In other words, the conclusion we'll have with our Toy theory are all tautological. We need to say the T word. A tautology cannot be unproven. It's not scientific, like this talk. It brings quite a few questions. First, it seems we are just shuffling numbers around. As you have guessed, we need to pronounce the T word. We have created a lot of tautology in just 20 minutes. So the value of all this will be solely posing the right terms. Probably we need a cost model to be useful. A slightly underrated question is, as a non-selfish version of this equation uses, why maximize value for everyone when you can for yourself? Does it even map reality? If our economic descriptions are going to say nothing, why do them? However, we have words in the common tongue English that correspond to different categories of value split. For example, if the shareholders get a negative value split, it's a bad investment. If the software users get a negative value split, it's software that makes their life worse and their outcome worse. If the workforce gets a negative split, it's called a sweatshop or open source. If everyone gets a positive greater than 0 deal, then it's ethical software. So we can intuitively sense the difference of nature depending on the value of V of A for someone. I will argue further that we do what we do as software engineer, you, not me, is relatively similar to the equation we've seen in this talk, but less formalized, of course. And tautologies are what economists do instead of going to lunch. For example, this paper presents a number of tautologies. Walras laws, the equation of exchange, microeconomic tautologies, the money multiplier formula. I don't know anything about it. The government budget constraints. Perhaps we've even discovered an existing tautology. And it goes further. Even Milton Friedman defends tautologies, viewed as a language theory, has no substantive content. It is a set of tautologies. Its function is to serve as a filing system for organizing empirical material and facilitating our understanding of it. And we need a last case study with a new character design for this case study. O'Connor is a signal processing researcher, and he wants to implement a new image resizing method, which is promising. Fortunately, O'Connor watched his talk before going to lunch. So for O'Connor, the problem is, I wonder if tilde V of the resizing method is above 0. The new thing might be a disaster. Maybe it works less good. So to make that model useful, we introduce two things. The first thing is conditional Bayesian rules. The value of R knowing event E will be the value of R if event E happens, and same with not E. Which let us decompose the bond across a Bayesian decomposition with a new box type, the yellow box, which holds events. And now you can write that equation, but it still doesn't give us anything. We need a second edition, a cost model, which will be unrelated to this talk. The cost model of O'Connor is software is written and maintained. Let's say the cost is writing it plus maintaining it, plus eventually gain from it. Let's write that. Estimated value 4K of R, knowing event B, which is the new method is better, is writing R plus maintaining R plus gaining from R. And if the method doesn't work because the resizing is worse, it's only writing R. So O'Connor introduced a cost model to make the theory and the talk useful. And now he can stumble across this more simplified equation with a way to evaluate if it should develop his method with a probabilistic estimate. A few people among you are working in finance, maybe. So this looks similar to pricing things, it seems to me. But I'm not in finance, so I don't really know. What do you think? Now we stumble across the original problem to pricing core. And the way to think about it is that to know the value of C, an existing artifact, is the minus value of C being deleted. Because up until now, we wrote about things that were going to be written and didn't exist yet. So it was easier to imagine their added value. But now we are going to try to price software that already exists. Let's imagine what would happen if it were deleted. Maybe you know the COCOMO method, which is a cost model estimation. So I don't know anything about it, but it exists. It's a widely used model that estimates effort, time, and costs associated with software development projects. What was proposed in the last half hour, a one-dimensional axis of value that nests, which is in a way a language definition that conflates time, effort, and cost. Software, when viewed by accountants and bookkeeping, consider IP as an equity, assets minus liabilities, which is also owned, but doesn't nest its value nor consider it as a common. Another way to say it is that accountants are not interested by how software are composed, because they only consider their owners. Instead of ownership, I argue that the term exposure that clearly states who will benefit from a piece of IP is a bit more apt because it works in equations. All those nice equations are only one model of the world, which is, as you have guessed, probably flawed. Some flaws I can envision is that not all code are written in source. It could be somewhere in the head of someone in the organizational oral structure. There is also the point of code without its social structure. It's not sure how useful it is. This talk was engineered to make things simple, but it also do as if people do not exist, but it seems people do exist. All in all, cost model seems to be the hardest part and is probably solved before and elsewhere. If there is any value to this presentation, it would be to show the terms that have to be evaluated. Do you have any question?
My first business took a year for the first product. I sold 0 copies, and the next product took another year, and I sold 2 copies. So you're in good company.
You use this for your own company, and what's the value of your core library?
No, I haven't used any of that.
Not a question, but a fun side note. You had the $100 trillion value of a new space age earlier, 300 years in the future. And in fact, if you assume a very reasonable inflation rate of 2.07%, then if you calculate it back, that is pretty much exactly the current value of SpaceX. So that works out.
Can we go back to the slide with the integral on it?
Let's get back.
The one where you're integrating over the value of things over time. Because there's a... it's technically answering the wrong question. That one, yeah. You're assuming it has a known payoff over time, like a bond, whereas the thing is, with particular for like a core library, it doesn't make money by itself. The money you put in, you're buying an option to do things in the future. You've effectively bought an exotic option on the states of the world in the future. So that's the integral you should be doing. I can explain later. A second point is that the kind of the interesting thing here isn't so much knowing the value of things, but it's actually more of a kind of capital allocation problem. If you imagine you have a view on like the states of the world and which ones are likely, and you want to know how much money you should, or rather how much time you should allocate to something. This is actually a kind of very common thing in finance, where you have a view about the world and you want to know how much money you should put on the bet. And there are optimal ways of doing this in certain things. If you try and just go for broke and optimize your overall return, then you go bankrupt. So you want to like optimize something called the Sharpe ratio, for example. There's quite a lot of work in this. We can have a chat. It's not really a question.
Can you go to the slide where you have some papers on tautologies?
Yeah.
Yeah, this one. So I noticed, do you also host a university? You see, it's
I'm sorry, could you speak a bit?
You also host a university, because I see that the first paper is from Auburn University.
Yeah, but I didn't realize that before you say it. That's not an ad. There were only two or three papers on tautologies, so I had to make a cut. I have some extra content because I was told to make extra content for DConf. So this is D-related. We do have a language support for value annotation that we can already use. To do means this probably has greater than 0 value, since it's worth it to work on it further. Deprecated. A keyword means this probably has negative value, since it's worth it to delete it.
Do we have a valuation for the term hack?
I advise to work on your to-do annotation and make them as precise and semantically rich as they could. I think there's a lot of value, not value, but mileage to be had from rich to-do values. And some newer languages have the to-do annotation as first class, but more as a way to not compile, I think.
Yeah, do we have any more questions? I don't have anything from the internet. And it looks like we're pretty clear here. So thank you.
Thank you.